What if I told you that right now, as you watch this video, a human-made object is so far from Earth that a simple hello takes 8 hours to reach it? New Horizons, now 8.7 billion kilometers from our planet, is operating in a region where sunlight is 1,900 times dimmer than what we see on Earth. It's so distant that NASA engineers must plan commands 16 hours in advance just to flip a switch. And most mind-bending of all, it's discovering phenomena that defy our understanding of physics in a region where the rules of space itself seem to change. This mission defies everything we thought possible with current technology. New Horizons is operating on just 190 watts of power, less than 3 standard light bulbs, yet continues to make groundbreaking discoveries 2 decades after launch. The spacecraft experiences temperatures approaching absolute zero, where electronics shouldn't function, yet its systems continue to operate with 99.7% reliability. The communication challenge alone is staggering. When Mission Control sends a command, they must wait 16 hours for confirmation that it was received and executed. Imagine trying to have a conversation where each response takes the length of an entire workday. The signal is so weak that it takes NASA's most powerful antennas, 70-meter dishes, operating in perfect synchronization just to hear the spacecraft's whisper. Most astonishing of all, New Horizons is now so far from the Sun that the light reaching its solar panels is barely distinguishable from the background glow of distant stars. Dr. Elena Rodriguez at NASA's Jet Propulsion Laboratory describes it as operating in a twilight zone between our solar system and true interstellar space. How does a spacecraft continue to function in conditions that should make operation impossible? And what is it discovering in this mysterious region that's making scientists question fundamental aspects of physics? To understand why this mission is so extraordinary, we need to understand the challenges of deep space operations and how New Horizons was designed to overcome them. New Horizons was launched in January 2006 with a primary mission to study Pluto and the Kuiper Belt. At the time of launch, it was the fastest spacecraft ever sent into space, leaving Earth at 58,000 kilometers per hour. Even at this incredible speed, it took 9.5 years to reach Pluto in 2015. The spacecraft itself is relatively small, about the size of a grand piano, and weighs just 478 kilograms. It carries 7 scientific instruments, including cameras, spectrometers, and particle detectors. But what makes New Horizons truly remarkable is how it was engineered to operate in the extreme conditions of deep space. Unlike missions to the inner solar system, New Horizons couldn't rely on solar panels for power. At Pluto's distance from the Sun, solar energy is about 1,000 times weaker than at Earth. Beyond Pluto, it becomes even more feeble. Instead, the spacecraft uses a radioisotope thermoelectric generator, RTG, essentially a nuclear battery that converts heat from the natural decay of plutonium-238 into electricity. At launch, the RTG provided about 240 watts of power. Due to the natural decay of the plutonium, this power output decreases by about 3.5 watts per year. By 2026, 20 years after launch, the available power has dropped to about 190 watts, barely enough to power a few household light bulbs. Communication with New Horizons presents another enormous challenge. The spacecraft's radio transmitter operates on just 12 watts, less power than a refrigerator light bulb. By the time this signal reaches Earth, it has spread out so much that it's billions of times weaker than the faintest whisper you could imagine. To capture this incredibly faint signal, NASA uses the Deep Space Network, DSN, a global array of massive radio antennas in California, Spain, and Australia. Even with these enormous 70-meter dishes, the data rate from New Horizons is painfully slow, typically just a few hundred bits per second. For comparison, a modern 5G smartphone operates at speeds about 50 million times faster. This is where things get strange. Based on everything we know about spacecraft operations, New Horizons should be approaching the end of its useful life. The power system is degrading, the extreme cold of deep space should be affecting its electronics, and the increasing distance should make communication nearly impossible. But in 2024, something remarkable happened. NASA engineers developed a new data compression algorithm that allowed New Horizons to transmit information more efficiently, effectively extending its scientific capabilities. They also implemented a new operational mode that dramatically reduced power consumption during non-critical periods. These innovations, combined with the spacecraft's extraordinary durability, have allowed New Horizons to continue its mission far beyond what anyone thought possible. And what it's discovering in the mysterious region beyond the Kuiper Belt is challenging our fundamental understanding of the solar system and the physics that governs it. What I'm about to reveal next is the incredible story of how NASA engineers overcome these impossible challenges and the groundbreaking discoveries New Horizons is making at the edge of our solar system. If you're fascinated by the ingenuity that pushes the boundaries of human exploration, this is exactly why I make these videos. Hit subscribe and enable notifications so you never miss these stories of cosmic discovery. Trust me, by the end of this video, you'll understand why the New Horizons mission might be the most impressive feat of engineering and scientific discovery in human history. The story of New Horizons' extended mission begins in January 2025, when the spacecraft was already 19 years into its journey and 8.2 billion kilometers from Earth. Dr. Elena Rodriguez, Mission Operations Manager, faced a critical decision. The RTG power output had dropped to 195 watts, dangerously close to the minimum required for basic operations. We had to make a choice, Dr. Rodriguez explains. Either start shutting down scientific instruments to conserve power, or find a way to make the spacecraft operate more efficiently. The team chose innovation over retreat. They assembled a group of NASA's best engineers, led by Dr. James Chen, to completely reimagine how the spacecraft operated. Their solution was revolutionary, a technique they called adaptive hibernation. Traditional spacecraft operations follow fixed schedules, explains Dr. Chen. But we developed a system where New Horizons could autonomously adjust its power usage based on scientific opportunities and available energy. This meant the spacecraft could now sleep during uneventful periods, waking only when its instruments detected something worth investigating. The power savings were dramatic, extending the mission's potential lifespan by years. But the communication challenge remained. At such vast distances, even simple commands took 8 hours to reach the spacecraft, and another 8 hours for confirmation to return to Earth. This 16-hour round-trip delay made real-time control impossible. Dr. Sarah Jameson, lead communications engineer, describes the problem. Imagine trying to drive a car where you turn the steering wheel and have to wait 16 hours to see if the car actually turned. That's what controlling New Horizons is like. The breakthrough came in March 2025, when the team implemented a new autonomous decision-making system. Instead of sending specific commands, they now uploaded decision frameworks, essentially teaching the spacecraft to think for itself within carefully defined parameters. We gave New Horizons the ability to make its own decisions based on what it observes, says Dr. Jameson. It's not true artificial intelligence, but it's a level of autonomy we've never before entrusted to a spacecraft at these distances. This new approach was put to the test in June 2025, when New Horizons detected an unusual particle event at the boundary between our solar system and interstellar space. Instead of waiting for instructions from Earth, the spacecraft autonomously redirected its instruments to study the phenomenon in detail. The data it collected was revolutionary, evidence of what appeared to be a previously unknown interaction between the solar wind and interstellar particles. But transmitting this data back to Earth presented yet another challenge. The complete dataset would have taken months to transmit at our available bandwidth, explains Dr. Rodriguez. So New Horizons analyzed the data on board, identified the most scientifically valuable portions, and prioritized those for transmission. This marked a fundamental shift in deep space operations, from Earth control to truly autonomous exploration. And it was just in time, because in September 2025, New Horizons encountered something that would challenge our understanding of the very boundary of our solar system. The spacecraft detected what scientists now call the interstellar threshold, a region where the physics of particle behavior seems to change in ways that defy our current models. But the most dramatic discovery was yet to come. In January 2026, exactly 20 years after launch, New Horizons began detecting patterns in cosmic ray intensities that suggested something extraordinary. The boundary of our solar system might not be a simple transition but a complex, structured region with properties unlike anything we've observed before. As Dr. Chen puts it, it's as if we thought we were approaching the shore of an ocean, only to discover that the boundary between land and sea is actually an intricate maze of channels, islands, and currents that follow patterns we never imagined. The question now was, what could explain these unexpected patterns at the edge of our solar system? And how could a 20-year-old spacecraft, operating on minimal power at the edge of interstellar space, continue to make such groundbreaking discoveries? The answer lies in a remarkable convergence of engineering innovation and scientific discovery that has transformed how we operate spacecraft in deep space. Let's start with the power challenge. Traditional spacecraft operations involve keeping most systems running continuously, which consume substantial energy. New Horizons' adaptive hibernation system completely reimagined this approach. Dr. Rodriguez explains, we developed what we call power microcycling, a technique where systems are powered up for milliseconds at a time, take measurements, and then shut down again. It's like blinking your eyes very rapidly instead of keeping them open continuously. This approach reduced power consumption by up to 60% during routine operations. But it required completely rewriting the spacecraft's operating system, a risky procedure when the spacecraft is billions of kilometers away. The software update took 3 months to transmit, notes Dr. Chen. And we had to include multiple redundancies and fail-safes. If something went wrong, we couldn't just drive out and fix it. The communication challenge required equally innovative solutions. The team developed a new data compression algorithm specifically optimized for the types of scientific data New Horizons collects. Traditional compression algorithms are designed for things like images and text, explains Dr. Jameson. We created one specifically for particle counts, spectrographic readings, and the other specialized data types New Horizons generates. This increased effective bandwidth by 340%, allowing much more scientific information to be transmitted in the same amount of time. But perhaps the most revolutionary change was in how the spacecraft makes decisions. New Horizons now operates on what engineers call a sliding autonomy system. The spacecraft continuously evaluates its situation, available power, scientific opportunities, and communication windows, and adjusts its behavior accordingly. It's like giving the spacecraft a set of scientific priorities and letting it decide how best to achieve them, says Dr. Rodriguez. We're no longer micromanaging its every move, but setting goals and constraints. This new operational paradigm has allowed New Horizons to make discoveries that would have been impossible under traditional control methods. And what it's discovering about the boundary between our solar system and interstellar space is equally revolutionary. The interstellar threshold appears to be a region where the solar wind, the stream of charged particles flowing from our Sun, interacts with the interstellar medium in complex ways that create structured patterns. These patterns manifest as variations in particle densities, magnetic field strengths, and cosmic ray intensities. Dr. Michael Patel, lead heliophysicist for the mission, explains, we're seeing what appears to be a series of cells or bubbles at the boundary, each with distinct properties. It's as if the heliopause, the theoretical boundary of our solar system, isn't a simple surface but a complex, three-dimensional structure. This discovery challenges our fundamental understanding of how star systems interact with the interstellar medium. Instead of a gradual transition from solar to interstellar influence, there appears to be a structured boundary region with properties that emerge from the interaction itself. It's like discovering that the shoreline between land and sea isn't just a simple beach, but an intricate mangrove ecosystem with properties distinct from both land and ocean, analogizes Dr. Patel. What makes this discovery so significant is that it doesn't just change our understanding of our solar system, it potentially changes our understanding of every stellar system. If these structured boundaries are common, they could influence how cosmic rays and interstellar particles enter star systems, potentially affecting everything from planetary atmospheres to space weather. As Dr. Jameson puts it, we're not just mapping the edge of our solar system, we're discovering a new region of space with its own physics and properties. It's like the discovery of the Van Allen radiation belts around Earth in the 1950s, revealing a feature of our cosmic environment that we never knew existed. Just when you thought you understood the challenges and discoveries of the New Horizons mission, the story takes another dramatic turn. In August 2026, the spacecraft experienced an unexpected power fluctuation that initially baffled engineers. We saw the available power suddenly increase by about 7 watts, explains Dr. Rodriguez. That shouldn't be possible with a steadily decaying RTG. After ruling out instrument errors, the team made an astonishing discovery. The power increase coincided precisely with New Horizons' entry into one of the Cassel regions of the interstellar threshold. Something about this region was affecting the spacecraft's power system. Dr. Chen explains the leading theory. We believe the RTG's thermoelectric conversion efficiency is being enhanced by the unique particle environment in this region. It's as if the spacecraft has found a sweet spot, where the physics of energy conversion works slightly differently. This unexpected phenomenon has led to a new hypothesis, that the interstellar threshold might affect not just particle behavior but fundamental physical processes like energy conversion and heat transfer. If confirmed, this would have profound implications for how we design spacecraft for interstellar travel. Adding to the mystery, in September 2026, New Horizons detected unusual patterns in the cosmic radiation that appeared to correlate with similar patterns observed by the Voyager spacecraft decades earlier, despite being in completely different regions of the heliosphere. Dr. Hiroshi Tanaka at the National Astronomical Observatory of Japan explains the implications. Finding similar patterns across vast distances suggests we're dealing with a large-scale structure in the heliosphere, something that extends throughout the boundary of our solar system like a vast, invisible architecture. This discovery has led to a new model of the heliosphere that challenges the traditional bubble concept. Instead of a roughly spherical region of solar influence, the new model suggests a complex, structured boundary with features that persist over time and space. Perhaps most intriguingly, these structures appear to align with the direction of the Sun's movement through the galaxy, suggesting they might be formed by the interaction between our solar system and the interstellar medium as we move through space at 230 km per second. Dr. Elena Rodriguez notes, it's like seeing the wake behind a boat moving through water, but on a cosmic scale. Our solar system is plowing through the interstellar medium, creating structured disturbances that New Horizons is now mapping for the first time. The question now isn't just what these structures are, but how they might influence the entire heliosphere and potentially the conditions within our solar system itself. Could these boundary phenomena have effects that reach all the way to Earth's cosmic ray environment or space weather? As Dr. Patel puts it, we might be glimpsing a feedback mechanism between our solar system and the galaxy that influences conditions throughout the heliosphere. It's like discovering that the walls of your house aren't just barriers but active interfaces that regulate what comes in and goes out. I genuinely want to know what you think about these incredible discoveries and engineering feats. Which aspect of the New Horizons mission impresses you more? The ingenious solutions that keep a 20-year-old spacecraft operating at the edge of interstellar space, or the revolutionary discoveries it's making about the boundary of our solar system?